let's write some recursive formulas for some sequences. The first step is determining what type of a sequence it is. We know how to deal with an arithmetic sequence and a geometric sequence currently. If it's more complicated than that, we don't have the tools yet. So let's see what kind it is. I usually go for the easiest one first, so I'm going to look for the common difference. Now, if you recall, to find the common difference, we take any term and subtract the number that came before. If we always get the same answer, it's common. We said before that's now minus previous. So let's do that with these numbers and see if we get a common difference or we get something else. When I do this, every single time I get that same difference, 5.4. So 5.4 is indeed the common difference because it's the one I get every single time. I know it's a pain, but it's generally best to check all of them, if not most of them, depending on how many numbers you have to deal with. Because sometimes you can even get the same difference 2 or 3 times, but you get different numbers other times. So we want to make sure that's the common difference. So for our recursive formula, we know now this is arithmetic because it has a common difference. So our formula, we need our starting number. Since we just have a list of numbers, we're going to say that's my first number. So it's going to start with u sub 1 is 13.5. To get any number in the sequence, my u sub n, I take the previous number, which is u sub n minus 1, and I'm going to add 5.4. And that is my recursive formula for this sequence. Let's look at another example. With this sequence, again, I'm going to assume the easiest first. I'm going to look for arithmetic. So I'm going to look at my difference. 170 minus 200 is negative 30. 144.5 minus 170 is negative 24.5. Sorry, negative 25.5. Either way, it's not a common difference. So we know it's not arithmetic. So we're going to look for the common ratio. Remember, that common ratio is now versus previous. Or I take any term in the sequence and I divide it by the term that comes before it. So let's do that with these numbers. As I go through, I got 0.85. I got 0.85. Now on these two, you notice I use the approximation symbol, this squiggly line, equal sign. This is not exactly 0.85. It was 0.8598, so it rounds, or 8498. It rounds to 0.85. Same thing with this one. It rounds to 0.85. So I can feel good about that. I do have a common ratio. My common ratio is 0.85. This is indeed a geometric sequence. So I will start and say u sub 1, because again I'll start with u sub 1 because I have a list. So I just have the first number, u sub 1. To find any number in this sequence, I take the previous number, and I'm going to multiply this by my common ratio, in this case 0.85. Let's look at one more example. Here's a geometric example, not a geometric sequence. Well, maybe not. I don't know. But as for drawing, this is something actually we call this a fractal. And a fractal is kind of like the idea of recursion in respect to figures in geometry. As you see, I'm doing the same thing each time. I'm taking a straight line segment and I'm putting a little triangle into it. Here I took each of those straight line segments and I put that little triangle on it. And I keep going on with this. It gets unwieldy very quickly. But let's see if we can make a sequence out of this. So we're going to count the number of line segments. The first figure, pretty simple, just has one segment. The second one has 4 segments. The third one, if you count those up, you'll get 16. And the fourth one, when we look at that, you're going to see 64. So let's say we want to find out how many figures is going to be in the 12th figure. To find out how many segments are in the 12th figure, this is where our recursive formula would be handy, or seeing the pattern. Now when I look at this 1, 4, 16, 64, hopefully it's pretty obvious this is not arithmetic. We're going up by 3, we're going up by 12, we're going up by a whole lot. So it's not a common difference. But if we look at the ratio, 4 divided by 1 is 4. 16 divided by 4 is 4. 64 divided by 4 is 4. So this is a geometric sequence. Now that we know it's geometric and we know what the common ratio is, we can say u sub 1 equals 1. U sub n equals 4 times u sub n minus 1. It's a geometric, so we're multiplying each term by the common ratio, and the common ratio is 4. And now we could go ahead and use this and figure out the next few figures until we get to the 12th figure, or you can plug that in, use your graphing calculator. You gotta love telemarketers. So back to what we were talking about, you could actually draw out all 12 figures. You could work out and list those out till you get the 12 numbers, or you can use your calculator, plug in the formula to the calculator, and get your figure, no matter how you do it. Your u sub 12 should be 4,194,304. So that is how many segments are in the 12th figure, and if you want to try to draw that, more power to you. I am not.